I'm going to take a step back from a lot of the solutions that we've seen and get back to some kind of fundamental basics of looking at the problem. So, slightly different approach. That's my bio. I'm basically ISACA chapter president, and I'm also research director for ISACA for Scotland. Thanks. Disclaimer: these views are my own, and nothing to do with ISACA or my company or anything like that. Just the usual thing. So here's the agenda. I'm going to see what dimensions of big data, basically stepping back, look at some of the things that people already mentioned. What are the risks with big data? Look at it from a risk perspective as well. Some existing solutions to incident response, what we currently do, and then the skill set for incident response, and then look at the problem and then come to a conclusion. So let's get going. So the ISACA view on what big data is, it has these three attributes. So we can see volume, obviously people have talked about that. The huge number of events and the amount of data we're generating as humans. You know, they talked about most of the data being generated in the last 2 years compared to the last 50. The velocity, obviously, the speed at which data is generated, and the variety, the unstructured nature of this data. So one of the things we've been looking at is, from an ISACA perspective, is the variation in the data. So that's an ISACA view on it. Then I thought, okay, let's have a scan around and see what other people think. And we got the IBM view on big data. So they're talking about volume in terms of 40 zettabytes of data, a huge number. The velocity, obviously, trading systems in the city, they generate huge amounts of data in rapid succession. Again, the variety of data, the variation in data is quite huge. And then the kind of the fourth V may be the veracity or the uncertainty of the data, because while you're gathering all this data, how sure are you that it's actually correct? Because otherwise it's the classic problem of garbage in, garbage out. You've got rubbish data, you're making an assertion on it. And actually from a cybersecurity perspective, the interesting thing is possibly that what if the cyber attackers now decide they're going to change data to try and influence the inferences that people make from data? So there's another potential risk there. But so let's go back to the basics. What are the risks of big data? So probably one of the big issues is that we're centralizing all this data into a single repository, right? And obviously the cloud's enabling us to put this in, but if the cloud's insecure, obviously the data's going to be vulnerable. But some risks might be amplified technical impact, because now you've got all your data, as I've already said, in a single point. If you change it, it could impact what you're doing. We've got the classic privacy issue. I don't know if it's been mentioned in this sessions before, but obviously you should be looking to protect people's privacy. But there's kind of a counterpoint to that. Obviously, we want to share data where it's going to help people from a medical perspective, but we want to protect people's privacy, so that's a challenge. And then the classic re-identification issue, the fact that you've got all this data, I can now work out that one of the people was working in this restaurant at this point in time and was doing something because I've been able to correlate data from different perspectives. So that's another risk we need to consider. So this is a kind of classic incident response type approach. So we have logging, we have network devices, we have IPS-IDS, we have antivirus, we have maybe file integrity monitoring, and then we have all that data feeding into our security event incident management system, which could be anything depending on your company. It could be any solution you decide to select. I give an example here of Splunk. The great thing about Splunk is it's really visual, really easy to search, really easy to find things. But you may have other solutions. You may have other QRadar, ArcSight, whatever. You pays your money, you takes your choice. So, but the fundamental question is, where are you now? So I've deliberately left a blank square here because everyone's different, okay? Different organizations will be at different levels of maturity. So for instance, who's logging all the data from all their servers, for instance? Put your hands up if you're logging all the data from all your servers. Anyone? There's a few. Right, who's logging whether privileged user accounts are being used? Okay, so again, a few. So it's going to vary from company to company how much logging is actually being done. And really, until you understand that fundamental point of what level of logging you're doing, you can't really make that step up to do any sort of really serious incident analysis. And then we've talked about the skills to be a big data scientist, okay? So obviously you've got this unique person who has these maths and statistics skills, programming skills, communication and visualization skills, domain knowledge and soft skills. So does anyone have anyone in their company like this? There's no one in the room. Okay, so these are quite rare people. So you're going to need to collaborate with different skill sets, in my view, to get this team of effective data scientists by bringing different skill sets together. Here in the room, we're obviously experts in cybersecurity, so we can bring that skill, but we may not have statistics knowledge. So if we look at it from an incident response perspective, that's pure data science. If we look at it from an incident response perspective, here's my view on this. So firstly, do you have domain knowledge? What problem are you trying to solve? Is it an APT, advanced persistent threat? Is it some other kind of thing you're trying to solve? Do you have the ability to gather all the data that you need for your incident response? That plays back to all the different controls I mentioned, the firewalls, the IPS, the IDS. Programming, in my view, all security professionals should be able to program. If you can't program, then in the new world, you're going to struggle to be effective, I think. Statistics, again, can you do analysis with statistics? Again, you may be a domain expert in cybersecurity, but you may not be a good statistician. And then visualization. Obviously, as humans, one thing which has come out of all the research I did earlier in terms of monitoring large, complex systems is that people are really good at visual patterns. They can detect, so if we were monitoring a power plant, they can see a slight variation in a graph to see that a sensor's out of position, but give them lots of data, they're unable to see it. So visualization is actually a key tool. But we've talked about artificial intelligence, and it's coming back really, because in the old days when I was working on artificial intelligence, it wasn't making that much traction. Now we've got this computational power and this storage power that we didn't have before. So AI is basically coming back. So we're now seeing my old favorite Bayesian belief networks coming back into fashion, and neural networks. And there are other tools and techniques which are coming back into fashion as well. But the fundamental point is, what are all these things doing? They're basically saying, if condition, then result. It's still basically an if-then-else, even though it's a complex Bayesian network, even if it's a neural network, that's basically what it's doing. So it's really a human aid to process the data. That's the key point, but it needs to be part of your overall solution. So here we go then. Who's a security practitioner in the room? Put your hands up, guys. Okay, we've got a few. Right, who can program as well? Oh, okay, so it's a good mix, good mix. Okay, so my view is, yes, let's do it. I think we should all be looking to program. So to get ourselves to understand the fundamentals of what issues we're dealing with. And there's lots of free MOOC, the Coursera as an example, data available. And the R programming language, which is a big data program, and Python is freely available. And you can basically train yourself up, is my point. So that's what we should be doing, so that we understand fundamentally what we're doing before we go into solutions. And then, again, defining the problem. How do we actually know what we're trying to solve with all this large amounts of data that we're gathering? And do we have the clear use cases beyond what we currently have for our solutions? So, again available critical thinking skills. Who's got critical thinking skills in your organization? Who's really can reason well about a problem? And in fact, there's another course there, How to Reason and Argue. So you can actually challenge the basics about how you believe you look at problems and solve problems. And I think that fundamental step back and understanding your reasoning approach is critical. And then there's even a course on big data, which I just threw in for fun. So, define the problem. So there's Bart there. So who knows about the Simpson Paradox? Anyone? Okay, blank looks. That's a bit of a worry. Okay, so two sets of data for Bart and Lisa. Bart and Lisa are from The Simpsons, if you didn't know, on their favorite baseball players. So Derek Jeter and David Justice here. So you can see the data is that David Justice has higher values for the seasons 95-96. But when you look at the combined value, Jeter has a higher value. So then if we look to the next season point, we get this anomalous behavior whereby even though David Justice has higher scores on average, the combined score is actually higher for David Jeter. So the point is there's an anomaly here, and it's called the Simpson Paradox, which basically means that even though you think there's a trend, you may get the opposite effect when you add two trends together, essentially. So if you're not an expert in statistics, you can get misleading results from big data, so it's just kind of a warning. So look at the data sets. What do you understand? So who runs honeypots here? Anyone? Okay. Yep. One person, two. So honeypots, okay, you want to gather data. So what's a quick way to run a honeypot? Well, run up a VPC in Amazon, and you can put different things on it and look to detect what data you're getting. So you might see, for instance, if you were, you might see that your systems are probed within 31 minutes, or 50% of systems are probed in less than 7 minutes. So the moment you connect this VPC, which obviously is in a controlled fashion to the internet, and you're logging that data, you can actually create a cheap honeypot and see what's going on. And you can construct things like that. That's a way of getting data. If you don't have that data, then you can go to open source repositories like the Verizon Veris database, which has a whole load of threat information which you can use to model with. So again, looking at the problem, how long would it take to discover various services if you put them on the internet? And here's some work from Verizon where they show the time to detect different services on the internet. But this all gives you an analysis of the threat that you're facing, which you kind of need to do if you're doing incident response. And it gives you an indication, in my view, how quickly the threat's detected, how quickly you should be patching that problem. So getting right down to the fundamental basics, we need to understand what use cases we're going to apply big data for. How are we going to apply big data? And what's the business case? What's the actual value we're going to generate from using this big data? Are we going to generate any value, or are we just experimenting in air? So first thing is to prioritize and scope the assets you want to protect. Look at the key attack vectors, which are phishing, web-based malware, endpoint and network anomalies, and look to build all that together to understand what problem you're going to solve with the big data. So looking to the future, read this article the other day, the military is looking to build an engine to uncover the humans behind the hacks. So one of the key issues when you're looking at incidents is attribution. How do you know who's actually attacking you? There's lots of guesses who the attacker might be, but I think what they're trying to do here is actually fingerprint the software to understand precisely where that code was compiled, which country it was compiled in, and how you can solve the attribution problem, which we all accept is a really big problem to solve. So in the future SIEM, I'm hoping that you should be able to get other feeds of intelligence, so things like Twitter. I find Twitter is a really useful source for information. Open source intelligence, you may pay for intelligence feeds depending on your organization, but the real bonus here is the attribution one in the bottom left-hand corner. So actually being able to understand where things are coming from. You've got at the bottom here, we've got the firewall, authentication, vulnerability scans, the standard things we already probably collect and put into. But then if we look at the endpoint and the network, we may be looking at more advanced solutions for endpoint. So artificial intelligence enabled endpoint and network solutions, which are giving even more precise data. So effectively your security incident event management system is now enriched with these additional feeds, which makes it considerably more effective. So in conclusion, I think the main thing is we're all driven by business imperatives. You know, I need to find a solution, but I need to find it yesterday. So we have that immediate imperative to deliver solutions, but at the same time, we need to understand what problem we're trying to solve. So we have to balance that fundamental point. Big data is the same, in my view, as ICS. So monitoring large industrial systems, it's the same problem. When I was working on large industrial systems, we were getting 100,000 events a second. So having to process that amount of data for a human is obviously almost impossible, but it's the same problem that we now have for security incident management. And BI solutions, there's lots of BI solutions been done in the past, enrichment of data. A lot of this is, in my view, directly analogous to what's happening with big data. So there's a lot of learnings to come from BI solutions in the past. Again, what I said before, formulate the problem. What problem are we actually trying to solve with big data? Are we just throwing computational power at what we think is a problem, or do we actually have a clear understanding of what we're trying to achieve? And that plays back to your business case. And yeah, what's the actual value? It's kind of the 6 V of big data. We talked about velocity, variety, and other things, but the value, what's the actual value of the solution that you're proposing, and how does that tie to an actual business case? You know, what's actually good enough to solve the problem right now? Maybe you don't need big data. Maybe you can get away with a visualization, which is good enough for the actual problem you're trying to solve. Maybe in the future you need big data, but right now you can get away with visualization. And not to forget the real-time element to incident response. This is, again, reiterated by the problems from other domain areas, like managing industrial control systems, where you've got huge amounts of data coming in, and you're having to understand and respond in real time. Because if you, for instance, in a cement plant, let's take a different example, if you don't respond to an alarm within 2 minutes, you can end up with 100 tons of material, which somebody's going to have to dig out. In the same response, in incident response, we all know if you don't respond to an incident and it's a critical incident, then potentially the business could collapse. So last point is really, I think everyone needs to be looking to upskill and add the added value of business and programming skills, and just broadening out and looking to broaden out your basic security knowledge beyond the fundamentals of just cybersecurity, and looking to add other skills and really demonstrate the value to the business of what you're actually doing. And with that, I'm done. Thanks. Good question.
I think you pulled us just about.
Yeah, I know, I realised that. Yeah.
So that was very good. So we do have time for a couple of questions. If people have some burning thoughts that they want to get across. Yes.
So actually, it's not a question. I would like to second. I think that was the fifth bullet point from the last slide. To consider whether we need big data, because I think big data is just implementation detail of the needs from the business. So you know, sometimes we try to build this big solution, trying to sometimes solve very simple problems, and I think that's worth mentioning, and to make the point that it's not necessarily always the right tool.
Yeah, I totally agree. That's why I'm saying you need to formulate the problem, and that's why I'm saying you should experiment with the big data environment to understand what it can do for you, as opposed to just saying, I've got a solution, I'm going to throw the solution at what I think the problem is.
Any other questions?
Can you just ask quickly what ICS and BI, the solution?
Oh yeah, sorry, industrial control systems. So used to work on power plants, so they're huge industrial control systems, and obviously they generate thousands of events and alerts. Effectively, it's the same problem as the security issues, really. BI is business intelligence, so we used to deal with 1.25 billion events in our business intelligence systems per day. So we're already used to handling large transactional data, which again is analogous to the security problem. So what I'm saying is problems from the past had exactly the same problem. We're still having humans in front of huge amounts of data trying to interpret it. So the fundamentals haven't changed. I think we just maybe got more tools to try and address the problem, but I still think you need to understand the problem you're trying to solve.
So do you reckon it's quite cyclic then?
Yeah, to some extent, but I think the big difference is now we've got more computational power. When I worked on Bayesian belief networks like 15 years ago, we struggled to get the data, and we didn't have the computational power. So the Bayesian belief networks I built were quite simplistic. Now you can build quite complex Bayesian belief networks because you've got the computational power and the data. So things have changed. You have technological advancement, and the digital universe has made huge differences.
What do you think of AI then? I mean, you heard that young man, Harry, earlier, he was mentioning user behaviour analysis, and we've had network behaviour analysis before that. Do you think AI is going to develop more now?
Yeah, I think so. I think we've seen we've had examples of IBM's Jeopardy solving program, Watson, okay, and that's done medical diagnosis, which is fantastic things, right? And somebody mentioned to me, I think you've seen it in the news, that a computer's been able to solve the Go game, right? So that's. On Harry's diagram, he said assisted machine learning, and then the far right hand, I think it was like free machine, no human assistance. But Watson was basically the classic AI system where they did interrogations and they built the thing. So that's human aided machine learning. In the Go case, I think it was just pure machine learning. So this is an interesting thing. So we can now actually just because computational power is like, well, it's almost like for free, but almost. But you can basically let the machine go and learn now. So that's really quite an amazing concept if you think about it, because you potentially, as it says in the song, Homo sapiens have outgrown their use. So, it may just be that the machine is maybe we are redundant, but not yet, hopefully. Thank you.
Okay, thank you very much, James.
Thanks.